Bounds calculations with Adam Maths Tutor. Bounds calculations involve identifying the possible range of values for a number that has been rounded or measured with a given level of accuracy. We do this using upper and lower bounds, and we can use these to assess the limits of accuracy for further calculations such as addition, multiplication, division, squares, cubes, etc. Here's the beginner question, one of the easiest questions that you're likely to find on this topic. Adam wants to build a fence around his garden. The garden is a rectangle measuring 12 meters by 15 meters. All measurements are rounded to the nearest meter. Calculate the minimum and maximum lengths of fencing needed to fence the garden. Since the measurements of 12 meters and 15 meters were rounded to the nearest meter, we will need to start by calculating the upper and lower bounds of what these numbers could have been before they were rounded. Putting my rounding line after the units column would be rounding to the nearest meter. To find the upper bound, I can keep the number the same and put a 5 after the rounding line, giving me an upper bound of 12.5. It can't actually be 12.5 since that would round up to 13, but by definition, the upper bound covers numbers that are strictly less than that value. For the lower bound, you can put a 5 at the end, but you need to remember to take away 1 from the number before the rounding line, meaning my lower bound was 11.5. Using the same approach for 15 meters, the upper bound would be 15.5. and the lower bound would be 0.5, but remember to take away 1 from the number before the rounding line to give me 14.5. The way I calculate the amount of fence that's needed around the outside of the shape would be by calculating the perimeter of the shape. The perimeter is all of the 4 lengths added together. Since a rectangle has opposite equal sides, a minimum length of 14.5 would be replicated on the opposite side, and a minimum length of 11.5 would also be replicated on the other side. So the minimum amount of fence required would be 2 lots of 14.5 plus 2 lots of 11.5, which would be 52 meters. For the maximum, I'll need to use my upper bounds of 15.5 and 12.5. The total perimeter would be 2 lots of 15.5 plus 2 lots of 12.5. which gives me a total of 56 meters. You can see that there's a relatively large difference between these two numbers, meaning if I went to buy some fence from a shop and only purchased 54 meters, it might be enough to cover the minimum distance, but it might not be enough to cover it if it was closer towards the maximum. On to the intermediate questions with a slight increase in difficulty. Adam is laying a carpet in a rectangular room which measures 3.8 meters by 4.6 meters to the nearest 10 centimeters. It costs £2.99 per square meter. What's the maximum it would cost? Finding the upper and lower bounds of 3.8 and 4.6. Rounded to the nearest 10 centimeters would be a tenth of a meter, meaning my rounding line needs to go after the tenths column, which is the first decimal place. My upper bound would be 3.85 and my lower bound would be 3.75. And for 4.6, my upper bound would be 4.65, but my lower bound would be 4.55. When laying a carpet, this would be a surface covering the rectangle, and therefore the area is required. Area is a multiplication, and I will get the largest value by multiplying my 2 upper bounds. So for this question, since it's a maximum, I'll be using 3.85 and 4.65. 3.85 multiplied by 4.65 is 17.9025 meters squared. Each square meter costs £2.99, so multiplying this by 2.99 would give me a total cost of £53.53 when rounded to 2 decimal places. Adam is attempting to catch an ostrich. It runs 17.2 kilometers in 0.3 hours, both rounded to 1 decimal place. Find its minimum and maximum speed. Rounded to 1 decimal place, my rounding line will go after the first decimal place, 0.2 and 0.3. My upper bound would be 17.25 kilometers, and my lower bound would be 17.15 kilometers. For 0.3, my upper bound would be 0.35 hours, and my lower bound would be 0.25 hours. Since I'm finding the speed, my speed distance time triangle might be helpful. So the speed will be equal to the distance divided by the time. In this case, I need to find the minimum and the maximum. To find the minimum, when using division or subtraction, it won't be as simple as just using the two lower bounds. The way you minimize your answer when completing a division would be to take the smallest value that you're dividing, so my lower bound 17.15, and dividing or sharing it into the largest possible value, which would be my upper bound of the divisor, 0.35. This will give me a speed of 49 kilometers per hour. Likewise, to find the maximum, I'll need to use my upper bound of the number that I'm dividing, 17.25, and divide this by the smallest possible value, which would be my lower bound, 0.25, giving me a maximum speed of 69 kilometers per hour. This will be similar when completing a subtraction. The table you can see will be helpful to find minimum and maximum amounts using upper and lower bounds of addition, subtraction, multiplication and division. On to the advanced question, one of the trickiest questions that you're likely to find on this topic. By considering bounds, we need to work out the value of m to a suitable degree of accuracy. To find the overall answer to a suitable degree of accuracy, we will have to consider bounds and find the minimum or maximum values for the calculation. When you see the words suitable degree of accuracy, you will need to find the minimum and maximum. 3.47 was rounded to 3 significant figures, meaning my rounding line was after the third significant figure of a 7, so the upper bound would be 3.475 and the lower bound 3.465. 8.132 was rounded to 4 significant figures. My rounding line would go after the fourth significant figure of 2, meaning my upper bound was 8.1325 and my lower bound 8.1315. To find the minimum, the original calculation involves a division. I'll need to square root the lower bound of s, which is 3.465, and divide this by the upper bound of t, 8.1325. This gives me a minimum of 0.22889. You should write down at least 5 or 6 decimal places and just finish by putting ... We'll do the same for our maximum. I'll need to take the square root of my largest value, 3.475, and divide this by the lower bound of t, 8.1315. This gives me a minimum value of 0.22924, and write down the same amount of decimal places followed by ... Now a suitable degree of accuracy is the largest amount of significant figures that you can round both of these numbers to, and will give you the same amount afterwards. So starting from the right hand side, so that I get the largest amount of significant figures, if my rounding line was to go after the fourth decimal place, you can see that this number would round to 0.2289, whereas this number would round to 0.2292. These numbers are not the same, so that would not be the suitable degree of accuracy. If I was to go back one more significant figure and put my rounding line after the third decimal place, the minimum would round to 0.229 and the maximum would also round to 0.229. Because these two numbers are the same, this would be my suitable degree of accuracy, so the overall answer to the question would be 0.229, and your reason would be the minimum and maximum both round to this value. Here's a question that I completed earlier. It appears as though I've made some mistakes. Pause the video and let's see if you can spot what they are, or write some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.